Welcome to Spring LIB.
7.85. So we're wanting to find the maximum angle at which a cyclist can maintain a constant speed uphill. So we're told various things, such as that we should assume that the cyclist can exert a average force on the pedals of 0.9 times their weight. Then we're given some information about the radius of the pedals and the rear wheel and then the gearing between them. And so here, basically, what we're wanting to do is if the bike is moving at a constant speed, then the net work being done on it is zero. And so if you're moving up a hill and ignoring any other sort of things that could be causing forces on the bicycle, that means that the work that's done by gravity, which will be negative as you go up the hill, is going to be will cancel out the work that the person riding the bicycle does. So if we consider in one revolution of the pedals first, and also we want to do this for assuming that the force is always straight down versus tangential. So for the force directed straight down, the work that the cyclist does will be 2 times this 90% of their weight. MR for the mass of the rider, times the diameter of the pedal motion. So in 1/2, because you'll go the diameter, because the force is directed downward, so the component of this displacement that's parallel to that is the diameter. And then there's the factor of 2, because in one revolution, one foot moves it half a revolution, and then the other foot moves it the other half. So you get 2 of these per revolution of the pedals. So with the pedals and front sprocket revolving once, the rear sprocket goes through 42/19 revolutions. And so the bicycle is going to move a distance of that, the number of revolutions, times the circumference of the wheel, which is 2 pi times the radius of the wheel, which is 34 centimeters. And so this is the distance along the incline. And so the change in height that we need to compare we need to use the change in height for computing the work done by gravity. They need to have a sine theta here, because you only care about the change in height and not the change along the entire change along the incline. So then this is the height that the person moves through. And so the work done by gravity, here's the work done by the rider, here's the work done by gravity, is the weight of the entire thing. So this is the mass of the bike plus the mass of the rider, times G times H, which we just said is 42/19, 2 pi wheel radius, times the sine of theta, which is what we're wanting to find, is theta. And with a cosine of 180 degrees, because the displacement is up and the force of gravity is directed downward. So we'll have a negative sign here. And so the work done by the rider plus the work done by gravity needs to be 0 in order for the speed to be constant. So 2 times 0.9 mr g d minus this expression here. So mb plus mr times g times 42/19, 2 pi wheel radius times the sine of the angle of the incline. So this is 0, and then we just set or solve. We solve for theta. So that's going to be the arc sine of 0.9 m the rider times d over the sum of the rider and bike spans is times 42/19 times pi times the wheel radius. And so this is 6.7 degrees. Now, if the force that the rider exerts is always tangential to the pedal motion, basically the only change is to the expression for the work that the rider does, because now the distance over which they're exerting that force, the distance that's parallel to the force, is now half the circumference of the circle, as opposed to the diameter of the circle. So 2, because we have 2 feet acting per revolution, and the rest of this expression is for what 1 foot does. So 90% of the weight of the rider, pi times the pedal radius. And so then we just repeat everything we did here, except with this other expression for the work the rider does. And we find that if you can exert force on the pedals tangential to their motion throughout, as opposed to only being able to exert the force downwards, you'd actually be able to ride up a slightly steeper incline, which we'll see in a moment. mg, mass of the rider g, times pi times the pedal radius divided by total mass times the sprocket ratio times pi times the wheel radius. And so this works out to be 10 degrees.